There is a clay tablet in the basement of Yale University's Babylonian collection that has been sitting in the same archive box for over 40 years. It is catalogued as YBC4789. Most visitors to the collection never see it because most visitors never ask. The handful of researchers who have requested access since the tablet was acquired in 1953 have all left without publishing on it. The official reason given is that the inscriptions are too fragmentary to support meaningful translation. That reason is not true. YBC 4789 was excavated from the ruins of Larsa in southern Iraq during a German salvage expedition in the 1930s, then sold to a private collector in Switzerland, then donated to Yale after the collector's death in 1952. It dates to approximately 2300 BCE. Its surface is divided into two distinct fields. The upper field contains a star map. The lower field contains a numerical sequence and a single line of cuneiform that reads, in modern translation, "The small sun returns when the great wheel completes." The star map shows our solar system, but it shows our solar system with two suns. If you want to see more deep dives into ancient mysteries that modern science is quietly catching up to, hit subscribe. I cover this kind of content every week, and what's in this video is going to change how you look at the night sky. Here is what makes the tablet remarkable. The second sun on the map is not depicted as equal to our own. It is smaller, drawn with shorter rays, and positioned along a path that loops far outside the orbit of the visible planets. The Sumerians who carved this tablet were not casual observers of the sky. They invented systematic astronomy. Their measurements of Venus transits, lunar cycles, and stellar positions remain accurate enough that modern astronomers still use Sumerian eclipse records to calibrate the dates of historical events. To understand why this matters, you have to understand how the Sumerians actually worked. They built dedicated observation towers in their major cities. The city of Ur alone maintained 3 of them, each staffed in shifts so the sky was never unwatched. The men who ran these towers were called Tupsar, Enuma, Anu, Enlil, scribes of the heavens. Their training took decades. They tracked planetary positions using mathematical tables refined over generations, measured celestial events against fixed sighting stones, and cross-checked their observations between cities. The astronomical archives at Nippur contained over 400 years of continuous records by the time YBC 4789 was carved. So, when a Sumerian astronomer drew a second body in our solar system on a clay tablet 4,300 years ago, the assumption that he was making it up requires more justification than it usually receives. The system behind him, the centuries of methodology, the cross-verifying observers, was not the kind of network that produced fictional astronomy. In 2017, a postdoctoral researcher at the California Institute of Technology named Dr. Mira Hadley happened to attend a lecture on Mesopotamian astronomy at the Getty Museum in Los Angeles. The lecturer mentioned YBC 4789 in passing as an example of an undeciphered text that probably represented religious symbolism. Hadley, whose actual research at Caltech focused on the orbital dynamics of trans-Neptunian objects, asked if she could see a high-resolution scan of the tablet. The lecturer, surprised by her interest, sent her one the following week. What Hadley noticed when the scan arrived was that the numerical sequence on the lower field of the tablet was not a list of religious offerings, as had been assumed. It was a series of ratios. The Sumerians wrote in base 60. Their mathematics was sophisticated enough to handle fractions, exponents, and algebraic relationships. The numbers on YBC 4789 were proportions, expressed as relationships between two quantities. Hadley recognized the format because the same notation appeared in other Sumerian astronomical tablets, where it was used to describe the relative angular positions of celestial bodies over time. The ratios on YBC 4789 were larger than anything found on the other tablets, but the structure was identical. She converted them into decimal and fed them into the orbital mechanics software her lab used to model trans-Neptunian objects. The software treats each input as a description of an orbit and outputs the most likely physical configuration that would produce those numbers. Hadley expected garbage. She had spent the previous evening showing the scan to a colleague over dinner, and they had laughed about the idea that 4,300-year-old clay would produce real orbital mechanics. She ran the data as a joke. The output was not a joke. What the software returned was a stable elliptical orbit around the Sun with a perihelion of roughly 90 astronomical units and an aphelion of approximately 600 astronomical units. The orbital period the software calculated was 3,612 years. That is not a number any Sumerian astronomer should have been able to produce. It is also a number that matches, almost exactly, the orbital signature of a hypothetical body that astronomers at Caltech had been searching for since 2014. They call it Planet 9. To understand what is happening here, you need to know what the modern astronomical evidence actually says. In the outer reaches of our solar system, beyond Neptune, there is a region called the scattered disk. It is populated by icy bodies whose orbits behave strangely. Specifically, a cluster of these objects, including the dwarf planet Sedna and a body called 2012 VP113, follow elongated paths that all point in the same general direction in space. The probability of this clustering occurring by chance is roughly 0.007%. In 2016, Dr. Konstantin Batygin and Dr. Mike Brown at Caltech published a paper proposing the most natural explanation for the clustering. The orbits are being shepherded by the gravitational pull of an unseen object roughly 5 to 10 times the mass of Earth, orbiting at extreme distance from the Sun on a long looping path. They called it Planet 9. The orbital period Batygin and Brown's models converge on is between 10,000 and 20,000 years for the larger mass estimates. For the smaller mass estimates with a tighter perihelion, the period drops sharply. The lower bound estimate produced by their 2019 refinement of the model is approximately 3,600 years. The Sumerian tablet says 3,612. There is no academic explanation for this. Hadley submitted her findings to the Journal for the History of Astronomy in 2018. She was politely told the paper required substantial revision. She revised it. It was rejected. She submitted it to 2 other journals. Both rejected it. By 2020, she had stopped trying to publish, but a copy of her preprint circulates in certain corners of the internet, and the math has been independently verified by amateur astronomers who simply ran the Sumerian ratios through the same software and got the same result. What Hadley did not know when she started her work was that she was not the first person to notice the ratios on YBC. 4789. In 1971, a German Assyriologist named Dr. Heinrich Lange, working out of the University of Tübingen, had been granted access to the tablet during a research visit to Yale. His field notes, rediscovered in 2019 by a graduate student going through the Tübingen archive, document his attempt to decode the same numerical sequence Hadley would later analyze. Lange worked with pencil and paper. He spent 3 months on the ratios and wrote in a letter preserved in the same archive that he believed the numbers described the path of a planet that does not appear in the Sumerian planetary lists. He was preparing the paper for publication when his access to the tablet was revoked. He was told the artifact required additional conservation work. The work was never declared complete. Lang died in 1989 without publishing. His notes were boxed up and forgotten until the graduate student Annika Vogel pulled them off a shelf and sent them to Hadley. Lange's hand-calculated period, done 50 years earlier with no orbital mechanics software, no Planet 9 hypothesis, and no modern Kuiper belt dataset, came in at 3,580 years. Hadley's software gave 3,612. The 2 values converge to within the margin of error of the original measurements. The Sumerians, on a clay tablet older than the pyramids at Giza, mapped the orbit of an object that mainstream astronomy did not begin to suspect existed until 2014, and at least 2 researchers working independently 50 years apart found the same answer hidden in the numbers. Now we need to talk about what the tablet says will happen next. The cuneiform line that runs across the lower field reads, in Hadley's working translation, the small sun returns when the great wheel completes. The phrase great wheel appears in several other Sumerian texts. It is consistently used to describe a complete circuit, a full revolution, a closing of a cycle. The phrase small sun is the same descriptor used in the upper field for the second body on the map. The implication is straightforward. The Sumerians believed the small sun was on a return trajectory. They tracked it, charted it, and calculated when it would come back. To calculate when, you need a starting point. The tablet does not give one explicitly, but it gives something close. Adjacent to the numerical sequence, the scribe carved a date marker, a specific astronomical alignment used in Sumerian record-keeping to fix events in time. That alignment, when run through modern celestial software, corresponds to the spring equinox of approximately 1568 BCE plus or minus 8 years. If the orbital period is 3,612 years and the last close passage was in 1568 BCE, then the next return falls in the year 2044. I want to be careful here. The math is the math. The tablet says what it says. But the assumption that 1568 BCE represents a close passage rather than some other point in the orbital cycle is exactly that. An assumption. It is possible the date marker represents a far-side observation, a recording of the body's position at aphelion, not perihelion. In that case, the next close passage would not be in 2044. It would be in approximately 3850 CE, but there is a reason to suspect the 1568 BCE date is in fact a close passage marker, and that reason has nothing to do with Sumer. The mid-2nd millennium BCE in the eastern Mediterranean is one of the most disrupted periods in the entire ancient record. Within a window of roughly 200 years, centered on 1500 BCE, the following events occurred. The eruption of Thera devastated Minoan civilization. Egypt experienced the catastrophe documented in the Ipuwer papyrus, including river anomalies, agricultural collapse, and sky disturbances. The Indus Valley civilization, which had thrived for over 1,000 years, abandoned its cities. The Xia dynasty fell in China, attributed in the text to fires falling from heaven and rivers running backward. Climate proxy records in Greenland ice cores show a sharp temperature drop and elevated atmospheric dust. Tree ring data from bristlecone pines in California document the most severe growth disruption in the last 5,000 years. Lake sediment cores in central Mexico show a sudden ash layer that does not match any known volcanic eruption from the period. Each of these is treated by mainstream scholarship as a separate event with separate causes. The conventional explanations work in isolation, but struggle to account for the global synchronicity. A small celestial body passing through the inner solar system would account for it in a single mechanism. Gravitational perturbation of the Oort cloud, sending a shower of long-period comets toward the inner system. Atmospheric disturbance from cometary debris. Climate disruption from elevated dust loading. Visible apparitions in the sky that ancient cultures would have recorded as signs and omens. And ancient cultures did record them. The Egyptian Ebers papyrus describes a star that became a second sun for 2 seasons before fading. Chinese astronomical records from the late Shang dynasty mention a guest star of unusual brightness that traveled the wrong direction across the heavens. Vedic Sanskrit texts from the same period describe Ketu, a celestial body without a fixed position that appeared in the sky during a time of catastrophe. Mayan codices, copied from earlier sources, refer to a wanderer that returns, with calendar markings that, when reconciled with modern dating, fall within the same window. These are not isolated mythologies. They are convergent observations from cultures that had no contact with one another, occurring in the same narrow window, describing the same kind of object. What Hadley's work suggests is that the Sumerians, alone among the cultures that recorded the event, understood what they were watching well enough to calculate when it would happen again. They recorded the orbit. They saved the math. They carved it into a tablet that was buried with their civilization and forgotten for 4,000 years. And the math points to 2044. Now let's address the obvious objection. If a Planet 9-sized body were on a 3,612-year orbit and is currently approaching the inner solar system, modern astronomy should be able to see it. The instruments we have today are vastly more sensitive than anything available even 20 years ago. Why have we not detected it? The answer is uncomfortable. We may have, or we may simply not be looking in the right place. Planet 9 has not been directly imaged. Its existence is inferred entirely from the gravitational behavior of the bodies it shepherds. Multiple survey programs have searched for it without success. The most recent estimate of its current position, based on the Badajan and Brown model, places it near aphelion, the farthest point from the Sun, where it would be exceptionally faint. This is consistent with the standard 10,000 to 20,000 year orbit. But if the orbit is in fact 3,612 years and the body is approaching perihelion, then it would not be near aphelion at all. It would be inbound, it would be brightening, and it would eventually become visible. In 2023, the Vera C. Rubin Observatory in Chile completed its primary mirror installation. The observatory's first decade-long sky survey, scheduled to reach full operations in 2025, will photograph the entire visible sky every 3 nights. It will detect any object brighter than magnitude 24, which is faint enough to capture a Planet 9-size body anywhere along the inner half of its orbit. If something is inbound, the Rubin Observatory will see it. That timeline is not coincidence. By the time the survey accumulates enough data to detect a slowly approaching body, we will be roughly 15 years from 2044. Whether the Sumerian math is right, whether YBC 4789 is what Hadley believes it is, will be answered by an instrument we have already built but not yet pointed at the relevant volume of sky. There is one more piece of the tablet that needs to be discussed, because it is the part that disturbs the people who have studied it most carefully. The cuneiform on YBC 4789 does not simply record the existence of the small sun and the timing of its return. It also describes what happens when the return begins. The instructions are fragmentary. The lower right corner of the tablet is broken, and the missing fragment has never been recovered. What survives includes phrases that translate roughly as "seek the high places," "the deep waters will rise twice," and "the great wheel disturbs the small lights at the edge of the dark." Take "the deep waters will rise twice." Sumerian flood mythology is well known. The story of Utnapishtim predates the biblical Noah by at least 1,000 years, but Sumerian flood references usually describe a single catastrophic event. The phrasing on YBC 4789 is different. It does not describe a flood. It describes a tidal pattern. A near-Earth passage of a 7 Earth mass body would produce exactly that effect. An initial tidal deformation as the body approaches, a relaxation as it passes, and a second tidal pulse as the gravitational gradient inverts on the trailing side. 2 risings. The Sumerian phrasing matches what modern geophysicists predict. The reference to the Great Wheel disturbing the small lights at the edge of the dark is the most striking of the surviving fragments. Modern astronomers, when explaining the predicted effects of a Planet 9 close approach to a general audience, often describe the same phenomenon in nearly identical terms. The gravitational influence of an inbound body would perturb the Oort cloud, sending long-period comets cascading inward. Some of those comets would impact Earth. The Sumerian scribe who carved this tablet 4,300 years ago either understood orbital mechanics in terms that should have been impossible for his civilization to know, or he was copying from a source that did. The phrasing matches the modern scientific prediction with an exactness that does not occur in cases of accidental similarity. There is a final detail that researchers familiar with the tablet have struggled to interpret. The numerical ratios on the lower field include a sequence that does not correspond to the orbital parameters of the small sun. It is a separate series. Hadley found that it described not a single orbit, but the gravitational influence radius of the small sun as it passes through the inner solar system. The radius given by the tablet matches the gravitational sphere of a body massing approximately 7 Earths, which is at the upper end of the Planet 9 mass estimate, and consistent with the smaller estimates that produce the 3,600-year period. The Sumerians did not just record the orbit, they calculated the body's mass from observation alone, with Bronze Age tools and Bronze Age mathematics, 4,000 years before Newton. Either we have severely underestimated the astronomical capabilities of a civilization we already credit with inventing systematic astronomy, or the Sumerians had access to information we cannot account for through normal channels. Both possibilities are uncomfortable. The first means a great deal of accepted history is wrong. The second is harder to articulate without leaving the bounds of mainstream discussion. Whichever is true, the tablet is real. The math is verifiable. The cross-cultural confirmation is documented. The astronomical predictions of Badigan and Brown remain on the table at Caltech, and the Vera C. Rubin Observatory is already collecting first light. YBC 4789 sits in its archive box at Yale. Hadley's preprint sits on a handful of personal websites. Heinrich Lang's notebooks sit in a drawer in Tübingen. The mid-second millennium BCE catastrophes are in the geological record where they have always been. The orbits of Sedna and the other extreme trans-Neptunian objects continue to behave as if they are being shepherded by something we cannot yet see. If the Sumerians were right, if the Great Wheel is in fact closing, then the next 20 years of astronomical surveys will produce one of two outcomes. Either the small sun will not be detected, the orbital math will not match real data, and the tablet will return to its category of intriguing but unverifiable artifact, or it will be detected. The orbit will match. The civilization that vanished from southern Iraq 4,000 years ago will turn out to have been right about something the rest of the world is only now beginning to suspect. There is no middle outcome. The body either exists on the orbit the tablet describes, or it does not. The data over the coming years will resolve the question one way or the other. We are, for the first time in human history, in a position to verify a Sumerian astronomical prediction against reality. The small sun, if it exists, is currently somewhere between the orbit of Neptune and the inner Oort cloud. It is moving. It is approaching. The Great Wheel turns, whether or not we are looking. The math is in a museum. The body, if it exists, is somewhere out in the dark. And in the next 20 years, we will know which one of them was wrong. If you want to see more ancient mysteries that modern science is starting to confirm, subscribe.